If you recall from the class, there was a question around what would be the time complexity of this Pascal's triangle algorithm that we had, right? So if you remember, there are two base cases. When k is equal to 1, we return 1. When k is equal to n plus 1, we return 1. And then there's the recursive case, which is just represented by this equation, right? So there are two recursive calls. So let's try and figure out uh, what are the number of steps that would happen for some small values of n, right? So uh, remember the levels are represented by n. So it goes from 0, 1, 2, 3, 4, and the k represents the number which has to be generated at that particular sequence. So level 0, number 1, right? So if we start with n is equal to 0, we'll have pt01, and that would be just this base case, right? So because k is equal to 1, so we'll return 1. So there's just one operation or one step, right? Then when you have n is equal to 1, there are two cases. So one is pt11, which is again the base case. So you have take one step, and pt12, which will come into this base case. So will again require only one step, right? Now in the second level, interesting things will happen. So let's see. PT21 will again take one step because it comes from the base case. And PT23 will again take one step because it will return from this base case, right? But what about PT22? So for this, you'll actually enter the recursive case. So you'll have PT11 plus PT12, right? Now, this, we already know how many steps it will take. So it'll take one step. PT12 will again take one step. And there is an addition inside here. So 1, 2, and 3. So three different operations. So in total, this will take three steps. Okay. Now, similarly, if you look at the level 3, go PT31 will take one step. PT34 will take one step, while PT32 will have this recursive call. Now, in this case, PT21, we already know takes 1. PT22, we just figured out takes 3. And then the addition operation. So we have 1 plus 3, which is 5, right? Similarly here, we have PT22, which takes 3. PT23, which takes 1. And then there's one addition. So we have 3 plus 1, which is again 5. Okay? So on, if you try to do this for other levels, so you'll see a pattern emerging. So we have PD41, the first will take one step, the last will take one, and then intermediately there'll be these recursive calls, right? So you'll have these many steps. So I did it here till n is equal to 5, right? Now let's try and sum this up together. So here we have different values of n. So going from 0, 1, 2, 3, 4, 5. And here we have the number of steps it takes. So for 0, it takes one step. For 1, it takes 1 plus 1, which is 2 steps. So we are summing up all the calls. For level 2, takes 1 plus 3 plus 1, which is 5 steps. For level 3, it takes 1 plus 5 plus 5 plus 1, which is 12, and then so on and so forth, right? So if you now try to see as the number of steps increases by 1, so in this way, you'll notice that as the number n increases by 1, the number of steps or the number of operations always increases more than 2 times. So if you look at this here, this is 5, which is 2 times 2 plus 1. This is 12, which is, the previous number of steps twice plus 2, which is 27. So the number of step always increases by 2 times. So if you increase n by 1, you double, slightly more than double the number of steps that are taken, right? So from 1 to 2, it doubles exactly, then from 2 to 5, and 5 to 12, 12 to 27. So the big worst case complexity of this algorithm will be order of 2 raised to n, or 2 to the power n, because as n increases by 1, you actually double the number of operations that are taken. All right. Okay.